Hello and welcome to our video on areas of triangles. I'm Mr. Chowdhury, and before we begin, the topics that you need to be comfortable with before we do this are, as usual, Pythagoras and trig, and you also need to be confident with area of triangles. There will be a link to go and watch those videos. Please go and watch them before you watch this one. If you are confident, however, let's plow on. So here's your starting point. What I'd like you to do is look at all of these triangles and work out the area of as many as you can. So just we're working through them. You're going to work out the area of all of these triangles. You can give your answers in units squared. So pause the video and have a go at that. Okay, so let's go through some answers. So the first one, the perpendicular height is 7, the base is 8. So I do 7 times 8 divided by 2, which gives me 28 units squared. The second question, the perpendicular height is 12. The base is 10. 12 times 10 divided by 2 gives me 60 units squared. For this one, we could do it in two different ways. We could use Pythagoras to work out the base, or we could use the perimeter that we're given. So you do 40 minus 17 minus 8, that gives us 15. And then we do 8, which is the perpendicular height, times 15 divided by 2. Which gives us 60 units squared. For this one, we're given the perpendicular height, which is 8. We can completely ignore this 6. It's not perpendicular. We don't want to use it. So we do 8 times 14 divided by 2, which gives us this answer, 56. And for this one, we do 15 times 10, because 10 is our perpendicular height, to get the answer of 75 units squared. And the last one, we can't answer the last question. We won't be able to do it. We're missing a perpendicular height. So this brings us on to the focus of this lesson. What do we do? How do we work out the area of a triangle when we're not given the perpendicular height? So here's our triangle, and the first thing we need to do is label these angles in the corner of these triangles. We need to try and label them. So triangle labeling conventions tell us that opposite length A is going to be angle A, and that's denoted with a capital A. The length is a lowercase and the angle is a uppercase. Opposite length B is going to be angle B, uppercase B, and opposite length C is going to be angle C. And this would, the letters don't matter. This would happen the same way regardless of what the letters are. We've just used A, B, and C. So just to recap, opposite length A is angle A, opposite length B is angle B, and opposite length C is angle C. So we need to try and work out the perpendicular height of this triangle to work out the area. So we're going to draw the perpendicular in, and we're going to draw a little square to denote that this is a perpendicular line. And we're going to call this length, we're going to call it H for height. We're going to call it H for height. We can't use Pythagoras. That's because the point where this perpendicular meets line B, or the base of this triangle, we're going to call it X. We don't know what CX is. We don't know what this length is. So we can't use Pythagoras. We can, however, use trigonometry. But to use trigonometry, we need an angle. So we're going to use angle C, because that's within our right angle triangle that we've created. So before we do anything, we need to label this little right angle triangle. So there we go, we've labeled it opposite, hypotenuse, adjacent. The hypotenuse is opposite the right angle. The opposite is opposite the angle that we have, and the adjacent is the one that's left over. It's next to the angle. Now that I've got this, I can see that I have the hypotenuse and I want to find the opposite. Therefore, I have to use sine. So I've written down the formula for sine. I can then plug in my values. So I know my angle is called C. So it's not called theta, it's called C. I know my opposite is called H, and I know my hypotenuse is called A. And now I need to rearrange this to make H the subject. So I'm going to multiply both sides by A. So I know H is equal to A sine C. So my height of this triangle is A sine C. Now that I know the height, I can start working out the area. So the area of a triangle is a half times height times base. I know what the height is, it's A sine C. I know what the base is, it's called B. So I can just write a half times A sine C times B. Now I'm just going to rearrange this so it's a little easier to remember. And because we've got a sine c, which is the same as a times c, sine c, sorry, we can rearrange this in any way because multiplication is commutative. So I'm going to rearrange it like this. So I've got a half times a times b times sine c. And the reason I've written it like this is because it's just easier to remember. A, B, C. Easy to remember. A half AB sine C. Now this is a very important formula because this now gives us the really powerful tool of working out the area of any triangle even if we do not have the perpendicular height. We can work out any triangle regardless of whether we're given the perpendicular height. The only thing we need to remember is that the angle we're using is between the sides that we have, right? So angle C is between A and B. It wouldn't have worked if it wasn't between A and B, but because they're between A and B, we can use this to work out the area of any triangle. So what we're going to do now is we're going to play a little game called Should We Use a Half AB Sine C? So the idea is there will be a diagram and you need to make a decision of whether or not you should use a half AB sine C. So I'm going to pause the video now and have a go. Do you think we should use a half AB sine C and why? So for this one, the answer is no. And that's because we're given the perpendicular height. So if we're given the perpendicular height, we want to be as efficient as possible. So using a half AB sine C is inefficient. It's not very efficient. So instead, we can just use B times A divided by 2 because we're given the perpendicular height. What about this one? For this one, once again, the answer is no. We don't need to use a half AB sine C, and that's because we're given the perpendicular height. There's no need to use a half AB sine C if we're given the perpendicular height. What about this one? Well, the answer is maybe. The answer is maybe. And the reason the answer is maybe is because we could use Pythagoras to work out the perpendicular height, or we could just use a half AB sine C. So it depends on which one you feel more confident with. If you want to use Pythagoras and work out the perpendicular height and go through that, you could. If you wanted to use a half AB sine C, you could. It just depends on your preference. Personally, I feel using a half AB sine C would be more efficient than doing 2 steps of using Pythagoras to work out the perpendicular height and then work out the answer from there. I think it's much more efficient to just use a half AB sine C. But the answer is still a maybe. What about this one? Should we use a half AB sine C? Well, the answer is no, we shouldn't. And that's because the angle that we're given is not between A and B. The angle that we need is this one. This one here is between A and B, and then we can use a half AB sine C. What about this one? Should we use a half AB sine C? The answer is yes. And the reason the answer is yes is because we're given the correct information. We're given the 2 sides and the angle encompassed by those 2 sides. So we can use a half AB sine C. But also the reason we can't use this perpendicular height is because we're not given the base. We're not given the base with regards to this perpendicular height. So we cannot just do the height times the base. If there was a way of working out the base, then fair enough, we could. But for now, in this question, from the information we're given, we cannot use the A times B divided by 2 version of finding the area. We have to use a half AB sine C. Now, before we move on, we need to look at the key characteristics, just so you have something to denote. When and what are the key characteristics of a half AB sine C? And if we have these characteristics, we should then definitely use a half AB sine C. So one of the first characteristics is that we are not given the perpendicular height. If we are not given the perpendicular height, we can use a half AB sine C. We should use a half AB sine C. If we can find the values of at least 2 sides, or we're given those, like you can either work them out or you're given them. You can find the value of at least 1 angle, or you're given that. So whether it's looking at a diagram saying, oh, that's the angle, or doing a little bit of maths to work out the angle that we need. And that the angle is between the 2 sides that we want to use. The angle is between the 2 sides that we want to use. Okay? And that is a very quick understanding of what a half AB sine C is. Hopefully that's helped and you're able to understand where this formula comes from, a half AB sine C, and that you have a better understanding on how to apply this. So the best thing to do now is to go onto Mr. Amoson's videos and have a look at half AB sine C questions and do some practice. If you're happy with Mr. Amoson's videos and you think you can do that and you want a bit more of a challenge, I suggest Corbett Maths and Dr. Frost. They have an abundance of questions that you can use. Hopefully this has been helpful, like I've said already. If there are any issues, you can just comment back and watch the video again. If there's anything that you're confused about, please watch the video again. And hopefully that will help. Go off and be productive, and I'll see you in the next video.